I am Dr. Jayalakshmi, Associate Professor, Department of Physics, Amit University, Coimbatore, Chennai. The presentation is on Introduction to Fiber Optics. What is fiber optics? Fiber optics is a branch of optics which deals with study of propagation of information in the form of light waves through transparent dielectric or material medium, so-called optical fibers. What is optical fiber? Optical fiber is a thin and transparent dielectric or material media that guides or transmits information as light waves using the principle of total internal reflection. A fiber optic cable consists of a bundle of individual optical fiber as thin as human hair, each of which is capable of transmitting information modulated onto light waves. Optical fibers are widely used for communications which permits transmission over a longer distance and at a higher rates than other form of wired or wireless communications. How optical fiber works? An optical fiber works on the principle of total internal reflection of light. Definition: when a light rays travel from denser medium to rarer medium and an angle of incidence is greater than the critical angle, then the light ray reflects totally. This phenomenon is known as total internal reflection. Condition of total internal reflection: the light rays should travel from a denser medium to a rarer medium and the angle of incidence must be greater than the critical angle. The angle of incidence is less than the critical angle, the light ray refracts into a rarer medium. When the angle of incidence is equal to the critical angle, then the refracted light ray travels along the interface of the two media. When angle of incidence is greater than the critical angle, then the light ray is reflected back into a denser medium and we get total internal reflection. The structure of the optical fiber. Optical fiber basically composed of two coaxial layers called core and cladding. Core is the physical medium that transmits light signal from the source to the receiving end. It is usually made up of a glass of high purity and has the index of refraction higher than the cladding. Cladding is the outer optical materials that surrounding the core. It has refractive index lower than core. It helps to keep the light within the core. Protective coating. This is the outer layer, plastic coating over the cladding that protects the fiber from various environmental influences and add necessary mechanical strength. Outer jacket is the outermost protective layer safeguarding the delicate optical fiber core and the surrounding component from damage and the environmental factors. The types of optical fiber. Optical fibers are basically classified into three types based on the materials and number of modes of propagation and based on the refractive index profile. So based on the material, it broadly classified into two types. One is glass fiber and second one is plastic fiber. The plastic optical fiber, the polymethyl methacrylate is used as a core material for the transmission of light. In the glass fibers, it consists of extremely fine glass fibers as the core material. And based on the propagation of optical fiber is classified into single mode optical fiber and multi-mode optical fiber. In single mode optical fiber, only one mode of light can propagate through the fiber. It has a small core diameter of 5 microns and the higher cladding diameter of 70 microns. The difference between the refractive index of core and cladding is very small. There is neither dispersion nor degradation, therefore it is suitable for long distance communication. Examples are signals such as cable TV, internet and telephone are generally carried by a single mode fibers which are wrapped together into a huge bundle. Multimode optical fiber. It allows a large number of modes of light rays travel through it. It has core diameter of 40 micron and cladding diameter of 70 micron. The refractive index difference is also larger than single mode fiber. There is a signal degradation due to multimode dispersion. It is not suitable for long range communication due to large dispersion and degradation of light signals. There are made by multi-component glass compounds such as glass-clad silica, clad silica, doped silica, etc. Based on the refractive index profile, fiber optics is classified into two types. One is step index optical fiber and graded index optical fiber. In step index optical fiber, the refractive index of core and cladding are constant. The light rays propagate through it in the form of meridional rays which cross the fiber optics during every reflection at the core cladding boundary. Graded index optical fiber. In graded index optical fiber, the core has non-uniform refractive index that gradually decreases from the center towards the core cladding interface. The cladding has a uniform refractive index. The light rays propagate through it in the form of helical rays. They ever cross the fiber axis. There are two parameters which defines the light acceptance and gathering capacity of the optical fiber and the angle the light can enter into the optical fiber, which are numerical aperture and acceptance angle. Numerical aperture is a number which defines the light acceptance or gathering capacity of a fiber. It is a measure of the amount of light that can be accepted by a fiber. Numerical aperture values are in the range of 0.1 to 0.3 for long range communications. Numerical aperture values are in the range of 0.4 to 0.5 for short distance communication. Numerical aperture is equal to sin theta I, which is equal to square root of n1 square minus n2 square, where n1 is the refractive index of the core and n2 is the refractive index of the cladding. Acceptance angle. Acceptance angle is the maximum angle at which light can enter the optical fiber. It's expressed as theta I is equal to sin inverse of square root of n1 squared minus n2 squared. Losses in optical fiber. Optical fiber experiences signal loss due to the absorption of light due to the presence of defect and impurities, and bending losses, scattering losses and imperfection at the core and cladding interface. It is usually expressed by attenuation is alpha is equal to minus logarithm of I output by I input, where I output is the light intensity at the receiving end and I input is the light intensity at the transmission end. In decibel, that attenuation is expressed as minus 10 by L logarithm of I output divided by I input in decibel, where L is the length of the optical fiber. Advantage of the optical fiber communication. Optical fibers have largely replaced copper wire communication because of safety. The fiber is non-conducting and is therefore safe in all environments. It uses light wave for communication, hence it is shock-proof. Weight. Fiber optic cables are made up of glass or plastic, hence it is lightweight and easy to install. Low power loss. An optical fiber offers low power loss which allows for long distance communications. Bandwidth. Fiber optic cables have much greater bandwidth, hence large amount of data can be transmitted over far distance than copper cables. Thank you.